Let us discuss linked lists. We can have singly linked list which have one pointer the next. We could have doubly linked list which have a prev pointer also. We could have circular linked list which don't have the null. The last node points back to the first node. We will start with singly linked list. So a linked list is basically a collection of nodes. You can see node 1, node 2, node 3. Every node stores some data which might be simple integer, which might be a character string like a name, or which might be record like person details. We have person, age, weight, name, some other fields, and then it has a address which is typically named next, and next is a pointer to the same type of node. It stores address of the next node in line, and it goes on, and the last node, the next pointer would be null. It is actually capital null. Let's say I'm talking of a linked list of integers. So all the nodes have some integral value, and every node has to store address of the next node. So this arrow simply means that this node has a field called next, which is like struct node star next, and that pointer is holding the address of the next node. And the last node, the next is null, so it is typically drawn like a grounding. And the first node, we have a special pointer called head. If the linked list is empty, head will be null because there is no node. If the linked list is not empty, head is pointing to the first node. Let us see how do we represent one node. Basically, this is how you declare a node in C. It's a structure having some data, and the next pointer is a pointer to the same data type. So these are called like self-referential or recursive data structure because the next pointer is pointing to another linked list of the same type, which can be empty or a set of nodes. In fact, this recursive nature allows us to write recursive functions very easily. Although recursive functions are costly, we can have a variety of things. Let's say I want to store names. So I can have a char name, maybe some array. I want to store names of people. In this case, the memory comes as part of the struct itself. Or maybe I am storing name as char star. Then I need to do an extra malloc for this pointer while I am storing any value. Or maybe I am storing details of a person. Maybe name, height, weight. You might have a linked list of records or structures, entities where you have more than one attribute also. Why not? That's how a linked list declaration looks like. How do I create a linked list? The first program creates a very rudimentary linked list. It creates nodes statically just for the demo. So node 1, we create a struct node and we fill in some data. Second node we allocate dynamically. So how do I allocate dynamically? I create a pointer to structure and I do a malloc size of that structure. In this dynamically allocated node, we put the next as the address of the previous node. We can access data. We can say pnode data, or we can say pnode next. Pnode next is the address of the next node, and on that we say arrow data. So this line will print 20 and this line will print 10, and like good practice we release all resources which we take, so we free. One more thing, normally it's a little inconvenient writing struct node all the time. You can create a type def. You can say this whole thing, I give a new name. I say type def struct node underscore t. And then wherever I'm using struct node, I can simply say node underscore t. Underscore t means it's a data type. So that is done in the second version. I have done the same thing, type def node t, and I have replaced struct node with node underscore t. So basically we have understood the concept of a head pointer. It all begins with head. In this little program, p underscore node is the head. Let's see some more code. So list 1. So we have struct node. This is how you create a head. Head is a pointer to struct node. Here we statically created a node and we initialize head to this, and again a static node, and node 1 dot next is address of node 2. So let's say we want to print the entire linked list. Whenever you create some logic, it's better to have a clear visualization. So let's say we have a linked list. I need to print this, and then I need to print this, and then I need to print this. I go in this direction. So I need to have a iterating variable standing here and which keeps moving. So that iterating variable obviously will be a pointer, struct node star. I took this PTR. So I situate it at head. That means PTR initially is here. And while PTR is not null, I print the data and I move PTR. How do I move PTR? I will say PTR is equal to PTR arrow next. So this is how I move. And we print the data in the current node before hopping to the next node. This simple loop prints the linked list. Let's see the next version. Now we are allocating memory. Many of the dots in the previous program have converted to arrow because now we have pointers to structures, not structures. Other than that, the code is exactly the same. Let's see the next one. Now we are trying to create functions. Normally nobody does this, that in the main we are manipulating the pointers and we are writing all the code there. So we create functions to add nodes and we create functions to display the list and all that. We will discuss these functions in the next small video.